Welcome to BKSS Academy. I hope you are in fine state. My dear students, we will discuss about recurrence relations and its solving techniques. As we know, there are three techniques for solving the recurrence relations. One is substitution method, next one is master theorem, third one is recursion tree. So first one we are discussing, that is substitution method. Suppose the function is telling t of n is equal to 1 if n is equal to 1, otherwise n into t of n minus 1 if n is greater than equal to 1. This is the one of the problem. So first, t of n is equal to n into t of n minus 1, what it is written here in the question. So for calculating this part, for getting the result of this t of n, this n is, it is one, it is defined things n, but t of n minus 1, what equation t of n minus 1 will get the result, that will be multiplied into n. So first we have to calculate what is t of n minus 1. So t of n minus 1 will be derived like this equation, t of n is equal to n into t of n minus 1. So according to that, t of n minus 1 will be t of n minus 1 into t of n minus 1 minus 1 as t of n minus 1, that is t of n minus 2. This is the equation. So by putting this value in this equation, we are getting t of n is equal to n into n minus 1 into t of n minus 2. So this is also undiscovered part of the equation. So for calculating this by the similar to this formula, so t of n minus 2 will be n minus 2 into t of n minus 3, because n minus 2 minus 1, n minus 1 format, that will be t of n minus 3. So that will be, so n into n minus, by putting the value of n t of n minus 2, this one, what my tn will be? Tn will be n into n minus 1 into t of n minus 2. In this way, this is the first step, this is the second step, and this is the third step. In third step, my value is n into n minus 1 into n minus 2 into n minus 3. This is t of n minus 3. This is my equation of third step. So here we will imagine, if in my first step it is t of n minus 1, in my second step it is t of n minus 2, in my third step it will be n into n minus 1 into n minus 2 into t of n minus 3. So from here we will imagine, if third step, first step it is n into tn minus 1, second step it is n into n minus 1 into t of n minus 2, in third step n into n minus 1 into n minus 2 into t of n minus 3. So similarly, at the n minus 1 term, so what will be my value? That will be t of n is equal to n into n minus 1 into n minus 2 into up to t of n minus 1 minus 1. That will be t of n minus n minus 1. That will be like this, t of n minus n minus 1, because the particular term will be subtracted from the n term. So this one will be t of n minus n plus 1, that will be t of 1. So this total sentence will be like this: n into n minus 1 into n into n minus 1 into n minus 2 into n minus 3 into n minus 4 up to t of 1. But in the initial question, when the n is equal to 1, the value will be 1. So in the next part, this t1 will be n, this equation will be n into n minus 1 into n minus 2 into n minus 3 up to t of 1 is equal to 1. Before term will be 2, before term will be 3. So n into n minus 1 into n minus 2 into n minus 3 dot 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 3 into 2 into 1. I hope you understand this equation. So for getting the time complexity, this is my answer. For getting the time complexity, so total equation is n into n minus 1 into n minus 2 into n minus 3 into 3 into 2 into 1. So first I will keep n into, from each term I will keep common, that is n. So n into, this n is here. For n minus 1 it will be, if I will take n as common, so n into 1 minus 1 by n. For n minus 2 it will be n into 1 minus 2 by n. Similarly for 1 it will be n into 1 by n. In this way my equation is derived from this equation. So from here we are first calculating how much n are here. If one n is here, next n is here, so up to n times n is here. By looking at the equation we are getting n times n is here. If n times n is multiplied, the result will be n to the power n into rest part of the things. So for getting the maximum variable, which is dominant term, this is the dominant term as compared to this one. So time complexity will be big O of n to the power n. This is the time complexity for the substitution method for this equation, where t of n is equal to 1 when n is equal to 1, t of n is equal to n into t of n minus 1 if n is greater than 1. Thank you.